Hi, today's Monday, May 11th, and if you're watching this, then you are getting ready to start your last unit for this school year. So this is all about area of a square, and we are starting our unit on the Pythagorean theorem and irrational numbers. So what we're going to do here is we're going to start by investigating some squares and their areas. Let's start with this warm-up. Without doing any calculations, which of the shaded regions you predict has the largest area? Take a second, looking just at what you see, which one might have the largest area? As I start to draw in things to bring your eyes to different smaller, maybe triangles or rectangles, you might notice you could take this and bring it over here. Which would allow us to do the same thing on this side. How many full squares are now shaded in for A? What do you notice about B? Which shaded area is larger? Well, we can take a look, and as I showed with my different drawings in the past slide, maybe you look at it this way. I can enclose the shaded area with 1, 2, 3, 4, 5, 6, 7, 8 squares. But if you notice, for example, these two squares, only half of it is shaded. So I started with 8 units squared. I have to take away 1, where the pink is. I can come over here, and here's 2 units. And again, I'm going to take away 1 unit, take away 1 unit. And as you can imagine, take away 1 unit, take away 1 unit. So I can take away 4 units squared. So A has 4 squared units. And B, maybe you see it a little different. Maybe you see 1 complete square here. But then maybe you notice here's 2 squares. Only half is shaded in. So half of 2 is 1. And again, there's 2 squares. Half is shaded in. So there's 1. And 1 and 1. 1, 2, 3, 4, and the middle 5. 5 units squared. So if you said B had the larger squared units, you would be correct. Now let's compare which square has the larger area. Before we get into activity 1, let's take a look at this launch activity. Which is larger, the combined area of the two smaller squares, A plus B, or the area of square C? By adding grid squares into this, it's going to make it a lot easier for us to see that we have a 3 by 3 area. And we know that the area of a square is the side squared, side times side. So the area for A is 9 units squared. For B, we have 4 by 4. So B is 16 units squared. And C is our 5 by 5. And so C has 25 units squared. 9 units squared plus 16 units squared equals 25 units squared. So A plus B is the same as C on its own. Next, you're going to be working with some shapes. Now, if you're watching this video, you are going to actually pause and you're going to go over to your ILC. And in the ILC, you are going to find an activity. That activity is 8.8.1. So it doesn't matter which class you're in. You are going to find this activity right here. You're going to go into this digital optional activity and you're going to give it a try. There we go. You are going to move around these different shapes and you're going to try to make all 5 of those shapes equal or create one square. After you've done that, you're going to come back here and we're going to answer some questions using those squares to find a total area of the 5 shapes. So here you have your 5 shapes: D, E, F, G, and H. And then you have these really nice 3 by 3, the 4 by 4, and the 5 by 5 square. You're going to move and rotate and flip these different shapes around and try to make a square. Then you're going to share your strategies. The answer was 25 units squared, which means that you could have put all 5 pieces together to make this large square, or you might have noticed that you could make these 2 smaller squares using the 5 shapes. Activity 2. In this activity, we're going to find the area of shaded squares. First, you're going to work on your own. Well, you are working on your own because you're watching this video. So, we're going to find the area of the shaded square in squared units. What's nice about this is that you already have a line enclosing the purple square. So start by finding the area of the black frame. So we're going to look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a 10 by 10. So you start with 100 units squared. If you notice, we have this really big rectangle here. That rectangle is 1 unit less than the length of the sides of the squares. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a 9 by 1 rectangle. So if I were to divide that 9 in half, I would have to remove 4.5 units squared. If you notice, going around to all of the sides, we have again this 9 by 1 rectangle, and we would be subtracting 5 units squared. 4.5 units squared from each side. So we're going to take away 4 groups of 4.5 units squared. Well, 4.5 plus 4.5 is 9, and 9 times 2 is 18. So we're going to subtract 18 units squared from 100, and we will end up with 82 units squared. Find the area of each of these shaded squares. So we have a white shaded square and we have a yellow. Again, we can see 1, 2, 3, 4, 5. You should be counting. And you should have gotten a 12 by 12 on the grid. If we take away these two sides, we can see our 10 by 10, which is 100 units squared of the white. Well, this is fun. I can see that this is a distance of 1, 2, 3, 4, 5. 5 by 5. And now we're cutting it into quarters. So if this is 25 units squared, the shaded part is going to be half of that. So 12.5. 12.5, 12.5, 12.5. 12.5 times 4. 50 units squared. Find the area of this square. As we're looking at this, we can see that we have these 7 by 3 21 units squared, 21 units squared, 21 units squared, and 21 units squared. Now we also can see the large square going around is a 10 by 10. Which is our 100 units squared. And if we were to combine two of these triangles, we would get 21 units squared and 21 units squared. What does that leave us in the middle? Well, here we know is 3, leaving us with a 4. Here's a 3, leaving us with a 4. So that must be 16 units squared. When we add this up, 42, 52, plus 6, 58 units squared. Could we also think 100 units squared, and let's take away these 4 white triangles. 7 times 3 is 21, divided by 2 is 10 and a half. There are 4 triangles that are 10 and a half, which is 42 units squared. So if I take away 42 units squared from 100, I would be left with 48 units squared. So what I was able to do is start with what I know, the whole square, and sometimes people call this the cutting method, where we are cutting out the unused areas. For today, we are going to skip through the Are You Ready for More, but we hopefully will come back and take a look at that later on next week. And now we're moving on to Activity 2. In Activity 2, oh, no, I was wrong. We are done. So, we looked at the second activity here, and we looked at the strategies. I talked about the different strategies that you may use. Some of those strategies for finding the area of a square. If you have a square and you know its side lengths, how would you find the area? Well, we talked about that for the area of a square. You know it's the square side times side, because the square has all 4 sides congruent. What needs to be true about 2 congruent triangles in order to compose them into a rectangle? Well, those 2 triangles have to be congruent. Now it's time for your cool down. For your cool down, you will get your paper handed out to you. And again, you will begin to section off and look for rectangles and squares within the shape. I will see you tomorrow in class.